Have you ever noticed how the AI assistants we use every single day are suddenly getting way better at solving really tricky problems? Well, it is not just your imagination. There's this super fascinating shift happening behind the scenes, and it's all about teaching AI a powerful new trick, how to actually think. So what is really going on? Let's get into it.
Okay, so look at this. On the left, you ask a really complex question, and you get back this single, blunt answer that might even be wrong. But on the right, for the exact same question, the AI shows its work. It lays out its reasoning step by step and gets to the right solution. So what's the secret sauce here? What makes that second response so much better, so much more reliable?
Well, it turns out the key isn't just building bigger and bigger models anymore. The real game changer is giving them stronger reasoning skills. This is what lets these large language models, LLMs, go way beyond simple Q&A. It helps them start tackling the complex, multi-step problems we actually want help with, like, I don't know, planning a detailed vacation or debugging a nasty piece of code. Now, this whole revolution is built on an idea with a bit of a technical name, Inference-Time compute scaling. But the concept itself is beautifully simple. Think about it. You and I, we often give better answers when we're given more time to think, right? Well, it's pretty much the same for AIs. This whole technique is about giving the model more thinking time when you ask it something, letting it process more deeply to come up with a much better result. So researchers are basically exploring four main paths to get AIs to reason better. But for right now, we're going to zero in on that first one, which is arguably where all the most exciting stuff is happening, that inference-time compute scaling. It's a way to make the models we already have smarter, right on the fly. So how in the world do you actually make an AI think longer? I mean, it's not as simple as just telling it to wait. Researchers have come up with some incredibly clever strategies to get these models to pause, to reflect on their own work, and to explore a bunch of different possibilities before spitting out an answer. Let's look at some of the coolest ones. All right, the first group of strategies is all about one thing, getting the model to slow down and check its own work. Kind of like we might do when we're solving a tough puzzle. It's about building in these little moments of self-correction. This quote is just brilliant. It comes from the research paper for the DeepSeek R1 model. Researchers actually saw the model generating phrases just like this all on its own when it was reasoning its way to an answer. And that inspired a technique where they add special wait tokens to prompts, which encourages the model to generate these longer, more thoughtful, and self-correcting responses. And then there's this other fascinating method called self-backtracking. The model is literally trained to recognize when it's heading down the wrong path. And when it does, it basically says, whoops, hold on. It inserts a special backtrack token, and then it just tries a completely different line of thinking. And what's so cool about this is that the model learns to do it all by itself. No external judge needed to tell it it's wrong. Okay, so the next set of strategies isn't just about slowing down. It's about broadening the search. Instead of just trying to find one single path to an answer, these techniques get the model to generate and then evaluate multiple possible solutions all at the same time. A fantastic example of this is a method called S-star, which was designed for writing code. First, the AI just generates a whole bunch of different code solutions. Then, it tests them all. If one of them fails, it actually analyzes the error and tries to debug it. And then, and this is the best part, to find the absolute most robust option, it invents its own tricky new test cases to separate the good code from the great code. Right, but there's a catch. All this extra thinking can be really expensive, computationally speaking. So this final category of strategies is all about making that reasoning process more efficient, getting that same high-quality answer, but with a lot less effort. Just look at the difference here. On the left, you've got chain of thought. It's super powerful, but it's also really verbose. It generates this long, winding explanation. But on the right is a newer idea, chain of draft. It's inspired by how we might just jot down quick notes for ourselves. It gets to the same correct answer, but by generating only the most essential steps along the way, which, you guessed it, saves time and compute power. So what's the real-world impact of all these clever techniques? Well, it is leading to some truly mind-bending results, where the size of the model suddenly matters a lot less than how well it can actually think. I mean, this was the literal title of a research paper, and it's a question that just grabs you for a reason. Could a tiny 1 billion parameter model really outperform a monstrous 405 billion parameter model, one of the biggest in the world? And the answer, incredibly, is yes. This chart shows the results. The massive 405 billion parameter model, and you can think of parameters as like the model's neurons, It actually scores lower on complex reasoning tasks than the tiny 1 billion parameter model that's been given a powerful thinking strategy. So the huge takeaway here is this. A smarter thinking process can be way more important than just raw model size. Now, there is some fine print here, an important trade-off. All this extra thinking isn't free. It requires a lot more computation, which costs more money, and yeah, it can make the AI's response time a little bit slower. It's that classic quality versus speed and cost dilemma that developers always have to balance. So, let's bring all this home. How are these advanced, kind of nerdy research concepts actually going to show up in the tools that you use every day? Well, the answer is they already are, in the form of thinking on demand. We're seeing this major industry trend where the biggest AI companies are adding what is basically a thinking toggle to their models. From Claude to Grok to IBM's Granite models, you can now often choose to enable a more powerful reasoning mode for your most difficult tasks. And this is almost certainly powered by the very inference-time scaling techniques we've just been talking about. And here's where it's all heading. The prediction from experts is that this is just the beginning. Pretty soon, having this kind of deep reasoning capability won't be some optional feature you have to turn on. It'll just be the standard. It'll be what we expect every AI to be able to do, just like we now expect them all to be good at conversation. And this leaves us with a really fascinating thought to chew on. As these AI systems become incredibly good thinkers, showing their work, correcting their own mistakes, we're going to face a brand new kind of question. How are we going to decide when to trust the AI's reasoning and when to step back and trust our own?